Today we are going to talk about the isoelectric point. Generally, amino acid will exist in the ionic form NH3 plus CH2 CO minus. So amino acids always exist in the ionic form. So nowhere it exists in the neutral form except at isoelectric point. So what is this isoelectric point? So at isoelectric point, pKa will be equals to pH. Where pK is equals to pH, there amino acid will exist in the neutral form. Okay, so there are three possibilities. The first one is pKa is greater than pH. The second possibility, pH is greater than pKa. Third possibility, pH is equals to pKa. So when pKa is greater than pH, protonation will take place. When pH is greater than pKa, deprotonation will take place. When pH equals to pKa, there 50% will be protonation form and 50% will be deprotonation form. Okay, now we'll see at we'll take this amino acid. We have NH3 plus CH2 COO minus. So at pH 2 we'll see. Okay, we'll take first pH 0, and the pKa of NH3 equals to 9.6 and carboxylic acid is 2.6. Okay, so in the both the cases pKa is greater than pH here, and here also pKa is greater than pH, because here pKa equals to 9.6, pH equals to 0. Here pKa is 2.6 and pH equals to 0. So in the both the cases pKa is greater than pH, and here the protonation will take place. So this is already, here we cannot protonate, only this can get protonate. NH3 plus CH2 COOH, and here charge will be plus 1. And then so next possibility will take higher pH, like pH equals to 10. So at this stage, how it will exist? We have NH3 plus CH2 COOH. Here the pKa of NH3 equals to 9.6 and carboxylic acid is equals to 2.6. So in now here pKa is less than pH. Here also pKa is less than pH. That means in the both the cases deprotonation will take place. So after deprotonation takes place, this NH3 will get converted into NH2, and this carboxylic acid converted into COO minus. So now we will have NH2 CH2 COO minus. So here if you will see, the charge will be negative. Next, if pH is equals to pKa, in this condition there is a possibility of 50% of this structure and 50% of this structure will exist. Okay, and here in the structure, imagine this is the structure 1 and this is the structure 2. So here this is structure 1 and this is the structure 2. The charge on the structure 1 is equals to plus 1. The charge on the structure 2 equals to minus 1. The final charge will be 0. So at point at which pH is equals to pKa, that point we will call as isoelectric point. At that point the compound will exist in the neutral form, so there will be charge will be 0 in this case. So this is about the brief introduction about isoelectric point. Now we'll go into the problems. So here we have a question. Calculate the pi of histidine after treating with 3 moles of base OH minus at pH 0. So we know that this pK is 9.6, this is 2.6, and this will be around 6.0. Okay. So now we are treating this one with 3 moles of OH minus, this first OH minus. So each time each OH will abstract proton from these 3 groups. Sorry. First we have to see at pH 0 how it will exist. At pH 0, all the cases, here pKa is 6, here pKa 9.6, pKa 2.6. in all the cases pKa is greater than pH, that means all will get protonate. So now it exists like this. So sometimes we have to calculate the pi value, we need to take only 2 pK values. Average of that one will be pi. So here we have 3 pK values, so we can't take 2 higher value, 2 lower values for this case. So for that, to calculate the correct isoelectric point, we have to go through this procedure. So at pH 0 it exists like this. So now we have treated with 1 mole of OH minus, so this will be a pKa1. so here we have carboxylic acid, we have NH3 plus, we have, and NH plus we have. So remember that which one is more acidic here. So here this is the neutral, right? Just remember that neutral amine will not donate and accept any electron. Okay, so because of that this don't have any role in this case this neutral amine don't have any role. So here we have to play with only these 3 groups. So here we know that pKa is inversely proportional to acidity, right? So the pK of this one is equals to 2.6, this 9.6, and 6.0. The acidity order will be carboxylic acid more acidic, then NH plus, then NH3 plus. That means when we have treated with 1 mole of OH, base will abstract hydrogen from the carboxylic acid. In the second case, second mole of OH will be abstracted from this NH, and third one will be from this NH3. Okay, so after treating with the first mole of base, the structure will looks like this. A positive charge, this is NH3 plus and CO minus, because the COOH is more acidic in nature. Because of that, the first OH minus will abstract hydrogen from the COOH. Next, so we have treated with the second mole of OH minus. So this is pKa1, so this will be pKa2. So we know that the second will be abstract proton from here. NH3 plus, CO minus, and we have a third OH minus this will be pKa 3. This NH2 and COO minus, right? Now we have this is structure 1, structure 2, structure 3. Now we will calculate the charge density in all the structures. So here the charge will be, this is plus 1 minus 1, this will be plus 1. Next here plus 1 minus 1, here 0, here minus 1. Okay, so here we have 3 pKa values: pKa1, pKa2, pKa3. pKa1 is for the carboxylic acid, that is equals to 2.6 approximately, and pKa2 is for the this nitrogen, this nitrogen, so that will be around 6.0, and third pKa3 is for the NH3, that will be 9.6. and here I said pKa1, that means carboxylic acid, pKa2 is means NH plus, pKa3 means this NH3. Okay, so now see, in case of pKa2, in case of pKa1 the charge is plus 1, in case of pKa2 charge is 0, in case of pKa3 charge is minus 1. Just remember that if you want to calculate the isoelectric point, that means the amino acid has to present in the charge form. If amino acid is present in the neutral form, you cannot calculate the isoelectric point. So here in this case amino acid is present in the neutral form, charge is 0 here. I mean I'm talking about net charge. So if net charge is 0, that pK we cannot use for that, is to calculate the isoelectric point. So this we can use for the to calculate isoelectric point as well as this one, because both the pK values having some net charge. Okay, whereas pKa2 is don't have any net charge, so this we cannot use for the to calculate the isoelectric point. Now we have only two pKa values. Now Pi is equals to 2.6 plus 9.6 by 2, and the answer will comes around 7.5. So this is the isoelectric point of histidine at pH 0. It's very simple, just whatever the pH he will give. So imagine that if he has given pH 10, so now what will happen? The structure will looks like this, will be deprotonation will takes place because here pH is greater than pKa. So in all the cases deprotonation will takes place, then it will become NH2, and then it will become CO minus, and this will become NH, like this. So it depends upon at what pH they are asking. Okay, so this is the way to calculate the isoelectric point when they ask like this kind of questions. And next so here we have tetrapeptide here. So here we have glycine, alanine, glutamate, glycine and lysine. Okay, and they asked us to calculate PA value at pH 7. Okay, so when they have mentioned the, let's imagine that they have here they asked pH 7, that means we have to take pKa value which is greater than 7, one pKa value which is greater than 7, another pKa value which is less than 7. That means imagine that we have 9.6, 10.5, 2.6. okay, these three values we have. So they asked us to calculate the pK isoelectric point at pH 7. So now we will take one value which is next higher to the 7, that means 9.6, plus the value which is lower to the 7, that is 2.6 by 2. So answer will become some like 6.1. Answer will come to be 6.1. So like this we have to calculate the isoelectric point when they ask pH. If they give 3 values, it's very easy to calculate. So we'll take one value which is higher than the given pH, another value which is lower than the given pH. But in this case they have given almost so many they have given, but don't get confused, it's very simple. In this case it's very simple. First we'll see about the alanine. So this 2.34 is for the carboxylic acid, and this 9.6 is for the NH3. Okay, so as I said that pKa has to have some net charge, then only we can use that one for the to calculate isoelectric point. Here this carboxylic acid is present in the neutral form. This is not present in the charged form. So because of that we cannot use this carboxylic acid pK value, we cannot use to calculate the isoelectric point. So this we can cross out. This we cannot cross out because NH3 plus is present in the charged form. Okay, now we'll go for the glutamate. So glutamate means we can take from here to here. This is glutamate. So here in the glutamate there we have amine group which is present in the neutral form, and carboxylic acid also present in the neutral form. So this we can neglect, this also we can neglect. But the side chain, the carboxylic acid, this side chain is present in the charged form. So because of that we cannot neglect this one, this will keep like that only. So now we'll go for the glycine from here to here. In the glycine both NH as well as carboxylic acid are present in the neutral form, so we can cross out both the pKa values. And this is called lysine. In the lysine this NH is present in the neutral form, so this we can cross out, and carboxylic acid is present in the charged form, this we will keep, and this side chain is present in the charged form, this also we can keep it. So now totally how many pK values are left? 9.64, this is the 1, 2, 4.29, 3, 2.18, 4, 10.53. So these are the 4 pKa values which are present in the charged form. So whatever pKa values which are present in the neutral form, those pKa values we cannot use to calculate the isoelectric point. Okay, only these four are present in the charged form. Because of that only we can use these four to calculate the isoelectric point. So now at what pH they ask? That is equals to 7. So now 7 means we will take one value which is less than 7 and one value which is greater than 7. So less than 7, one value means 4.29 plus which one value which is higher than 7 equals to 9.64 by 2. Answer will come out around 6.96 will come. Okay, and if they ask at pH 4, what is the isoelectric point? So now we'll take one value which is greater than 4 and one value which is less than 4. The value which is greater than 4 equals to here 9.64. The value which is less than 4 here 2.18 by 2. So we can calculate the answer here. And if they ask at pH 10, and now one value which is higher than 10 is equals to 10.53 plus the value which is lower to the 10, 9.64 by 2, will get answer. So it's like that. So whatever pH they will ask, So you need to take one value which is greater than that pH and one value which is less than that pH. That means greater than means next immediate number. So here at pH 7 there are two values which are greater than 7, that is 9.64 and 10.53, but here we did not take 10.53, we have taken 9.64 means immediate number. So this is the way to calculate isoelectric point when they give this kind of peptide. Next so there are some amino acids like sulfur and oxygen containing amino acids. So like aspartic acid, glutamic acid, cysteine, tyrosine. So these four amino acids, so they are having three pKa values, pKa1, pKa2, pKa3. Always remember pKa1 is for the carboxylic acid, pKa2 for the NH3 plus, pKa3 for the side chain group. Okay, so for these four amino acid we have to take two least pK values to calculate isoelectric point. So if they have given 3 pK values for let's imagine that aspartic acid, we have aspartic acid means this one. O and COO. The pH of NH equals to 9.8, this is equals to 2.1, this will be 2.9. so here we have 3 pK, this pKa1, pKa2, pKa3. So for these four amino acid we have to take two least numbers, that means pKa1 plus pKa3 by 2, 2.1 plus 3.9 by 2, this answer will comes to be 3. So we can cross check this one, how we can cross check this one. So at pH 3 how it will exist. So whatever pi value you are getting here, just means pi value you got 3. Okay, now take pH equals to 3. At this pH, this form, this amino acid has to exist in the form where the net charge should be 0. Okay, so now we'll see how it exists at pH equals to 3. Okay, so in this case here pKa is greater than pH, here pH is greater than pKa, here pKa is greater than pH. In this case protonation takes place, in this case protonation, and here deprotonation takes place. After protonation deprotonation takes place, this exists as NH3 plus CH, CH2, COOH minus. So now we'll see the charge. Here charge we have one positive charge, one negative charge, the net charge will be 0. So that means, so for these four amino acids we can take two least values of pK values, so that from there we will get the pi value. Okay, you can cross check with the whatever value you get here, pi, that you can cross check how it existing at that particular pH. Next, for basic amino acids, we will take two higher values. Okay, like histidine, arginine, and lysine. Okay, and here we have NH2 CH, NH2 plus CO minus. So this pKa 8.9, this pKa 2.2, this pKa 10.8. So for basic amino acids we have to take Pi is equals to pKa 2 plus pKa 3 by 2. Always remember, pKa 1 means that is for carboxylic acid, pKa 2 is for NH3 plus, and pKa 3 is for the side chain group. So this is side chain group. Okay, so now we have 10.8 plus 8.9 by 2. This comes out to be so this will comes 9.85. so now we will see at 9.85 pH how this will exist at 9.85. so in this case deprotonation will takes place because pH is greater than pKa, and here also deprotonation takes place, and here protonation takes place because pKa is equals to 10, pH equals to 9.85. let me take another paper. So here 10.8 is the pK of this one, and 2.2, and here 8.9. so at pH 9.85 how it will exist. So this will be deprotonation because pH is greater than pKa in this case. Same here, pH is greater than pKa, deprotonation, but here protonation will take place. That means it exists like this. NH3 plus. So here +1 -1, total charge will be 0. Okay, for basic amino acids we will take two higher pKa values to calculate the isoelectric point. For amino acids like sulfur and oxygen containing amino acids we will take two lower values to calculate the isoelectric point. So this is about the isoelectric point, how to calculate. Thank you.